Today we are going to learn constructors and destructors. The constructors of a class are special member functions that have the same name as the class name, and their job is to perform memory allocation and object initialization, such as assigning values to data members and open files and so on. Note that constructors have no return types and values. For example, this is the class base. We have two constructors. One takes no parameter and another takes 5 parameters, and you can see that their names is the same as the class name, and they have no return values and return types. Unlike other member functions, a constructor can have a member initialization list. Take a look at this example. In this class derived, the constructor takes 5 parameters, and in this constructor we want to pass these 5 constructors to the base class constructor, and in that case we can use this member initialization list to pass these parameters to the constructors of the base class. Actually, to pass some parameters to the constructor of the base class, we have to use member initialization list. We cannot explicitly call the base class constructor in the derived class. And the constructors are typically defined as public. And you define constructors to be protected only if you want to make the class an abstract class. And you recall that abstract classes are those that cannot instantiate objects. Then you may ask, why do abstract classes need constructors? Because we cannot use them to instantiate objects. Well, abstract classes may also have data members, and these data members may also need to be initialized. The destructor of a class is a special member function whose name is the same as the class name, but preceded by this tilde. The destructor has no return values and return types, and also it has no parameters. Therefore, a class can only have one destructor because they have no return types, no return values, and no parameters. In comparison, a class may have multiple constructors with different parameter types, and typically you may have one constructor with some parameters and one constructor without any parameter, and actually that's called the default constructor. In this class base, you have this constructor with some parameters and also this constructor with no parameters. So the constructor that takes no argument, or that has the default value for all the arguments, is called the default constructor, such as like this class name parentheses, and this has no parameters, or it has some parameters, but every parameter has the default value. In that case, this is called the default constructor. And the default constructor is invoked when you instantiate an object without passing any parameters, like this. If in your program you did not write any constructor, then the compiler will automatically generate a default constructor for your class. Note that if you do have some constructors, then the compiler will not automatically generate a default constructor for your class. The compiler generated default constructor initializes the member variables of a class using their respective default constructors. So the constructor of a class is called automatically when an object of that class is instantiated. There are 2 ways to instantiate an object. One is to instantiate as a variable, like this, and in that case the memory is allocated in the stack. And another way is to instantiate using new. In that case the memory is allocated in the heap. The constructor is called automatically when an object goes out of scope or it is deleted using the keyword delete. For the objects that are instantiated as variables, when the function or the block that this object variable is defined returns, then which means that the object variable is out of scope, then the destructor is called automatically. And for objects instantiated using new, we must explicitly use the keyword delete to invoke the destructor. And if we forget to explicitly delete the object, then the object will stay there forever, even after your program terminates. This is called a memory leak. And this explains why sometimes, if for a long time you do not shut down your laptop, you may feel that it keeps getting slower. That's because some of the software that you run on your laptop have memory leaks, and the memory that your program can use gets smaller and smaller. That's why your laptop may become slower. And to instantiate an object, we need to allocate the memory somewhere. And there are two places that we can allocate the memory: stack and heap. The stack is used to store variables. When a function or block is entered, the variable defined in that function or block is stored in the stack. And when the function of the block finishes, then the stack space allocated for the function or the block is released automatically. Then the destructors of the object variables defined in that block or the function is called automatically. When we instantiate an object of the derived class, the constructor of the base class is called automatically, and then the constructor of the derived class is called. So the constructors are called from inside to outside. And this makes sense because you have to build the inner layer and then you build the outer layer. This is like growing an onion. So you have to grow the inner layer and then grow the outer layer. When we destroy an object of the derived class, the destructor of the derived class is called first, and then the destructor of the base class is called automatically. So the destructors are called from outside to inside. And this makes sense too, because you have to destroy the outer layer and then destroy the inner layer. This is like peeling an onion. So you have to peel the outer layer and then peel the inner layer. Now let's take a look at some examples. So here we have a class base. And in the base we have a default constructor. And this is a constructor with some parameters, and this is a derived class. In the derived class we have a constructor and also a destructor, and in the base we also have a destructor here. And in the base constructor, in the default one we print out in base default constructor, and in this base constructor with some parameters we set in the base constructor, and in the base destructor we set in the base destructor. And this is the derived class constructor. We output in derived constructor, and in the destructor we print out in the derived destructor. Now let's take a look at the main function. Here the main function has only defined only one object as variable. Let's compile and see what will it print out. Okay, so this is the result of executing this one line of code. This one line of code basically instantiates a derived class object. As we said, it first called the base class constructor, and then called the derived class constructor, and then after the main function returns, this object is out of scope. Then the destructor is automatically called. When the destructor is called on the derived object, class object, then the destructor of the derived class is called first, and then the destructor in the base class is called second. So that's why we have these 4 lines of output. Now let's take a look of if we have a function f. Let's take a look. So this function f is very simple. We print out entering this f, and then we just instantiate another object, and then print out leaving f. Let's compile and run. Okay, let's take a look. Well, first, when we execute the main function, the first line is this one. We first execute this. As we said, we instantiate a derived class object. We first need to call the base class constructor and then call the derived class constructor. So this is the result of calling the base class constructor, and then this is result of calling the constructor in the derived class. And after that, we call this function f, right, in the main function. Here we come to this function f. First, print out entering this f. Okay, this is that, and then we instantiate another object, derived object 2. Here we first need to instantiate the we first need to call the base class constructor and then call the derived class constructor, and then we execute leaving f. And after we finish this leaving f, this statement cout, this object is out of scope. When basically what I'm saying is, when f function returns, this object variable is out of scope. When it is out of scope, we need to call its destructor. And when we call this destructor, is the destructor of the derived class is first called, and then the destructor of the base class is automatically called. Right? That's these two. These two are generated when we exit f. Okay, and then after we finish executing f function, then the main function returns. When the main function returns, this derived object 1 is out of scope. So then the destructor of this derived class object is called. So then the destructor of the derived class is called first, and then the destructor of the base class is called second. So that's why we have this output. Okay, so now let's also take a look of this exhibits this demonstrates the scope of a main function and also the scope of a function. What about the scope of a block? Now let's take a look at this case. A block means that some piece of code that you use this parentheses to within this pair of parentheses. So in this main function, we have a block. In this block, we instantiate a derived class object variable, derived object 1. Now let's compile and run. Okay, now let's take a look. First, when we execute this main function, first we enter this block. Okay. Once we enter this block, we instantiate this object, which means that the constructor of the base class need to be first called, and then the constructor of the direct class need to be called. So the constructor of the base class is called, the constructor of the direct class is called. That's the output of these two statements. And then we exit this block. Then when we exit a block, the object variables defined in that block are automatically out of scope. Then their destructors need to be called automatically. So the destructor of this direct class is called, and then that's why we have this output. The destructor of the direct class is called, and then the destructor of the base class is called. After we exit from this block, we enter f. We enter this function f, and that's similarly. So we have entering f, then the base class constructor is called, then the direct class destructor is called. Then we leave f. When we leave f, the destructor of this direct class is called automatically, and let's generate this output. Then generate this output. So what's the difference between putting this block or not? Comparing this, we have this line for code or this line. The difference is, if we do not use this block, then this object is out of scope when this main function returns. And if we use this block, then this object is out of scope when this block finishes. All right. Okay, so the destructor should always be declared as virtual. So you can see that the destructors in this function, we always define them as virtual. The base class destructor is virtual. The direct class destructor is also defined as virtual. Why? So the difference between the destructor being non-virtual and the destructor being virtual happens when we use a base class pointer. Base class pointer points to a direct class object. In this example, base class pointer points to an object of the direct class. And in that case, when we delete the base class pointer, if the base class destructor is non-virtual, then only the base class destructor is called. So the destructor of the direct class is not called, and then that may lead to memory leak. And in this example, you see that in the constructor of this direct class, it allocates memory. Use new to allocate memory. And if this in the destructor of this direct class, we delete the memory. And if the destructor of this direct class is not called, then this memory will never be released. So then we do have memory leak. And in comparison, if this base class destructor is virtual, then the direct class destructor is called, which will automatically trigger the base class destructor to be called. Then we will not have a memory leak problem. Let's take a look at this example. Compile. And run. Let's take a look. Okay, in this main function, we first print out this, and then we use new to instantiate a direct class object, and this direct class and then we use new another direct class object and assign it to a base class pointer. Here we assign it to a direct class pointer, and this assign it to a base class pointer. And here we delete this direct class pointer, and then delete the base class pointer. Okay, so when we use new to instantiate this object, the base class constructor is called, and then the direct class constructor is called, and then similarly when we use new to generate to instantiate this object, is also the base class called, and then the constructor is called, then the direct class constructor is called. So that's why we have this first called in the base, and then derived the base, and then derived. And then here we call delete the direct class object. When we delete the direct class pointer, when we delete the direct class pointer, the destructor of the direct class is called first, and then the base class destructor is called second. And similarly, if we call delete the base class pointer, still the same thing. The destructor in the direct class is called, and then the destructor in the base class is called. This is because we define the destructor to be virtual. And let's see what if we do not define it as virtual. Compile and run. Okay, so you will see that for these two statements, we print out this stuff. That's the same thing as before. And similarly, if we delete the direct class pointer, then the direct class destructor is called first, and then the direct base class destructor is called. But if we delete the base class pointer, although it points to an object of the direct class, only the base class destructor is called. The destructor of the direct class is not called, which may lead to memory leak.